Hey guys, Jake here, coming at you with another math problem today. Today I'm going to be showing you how to do this problem here. We're going to use Euler's method with a step size of 0.2 to estimate y of 1, where y of x is the solution of the initial value problem, y prime equals xy minus x squared, and y of 0 equals 1. So I'm showing you how to do this problem because this is going to use one of the equations on my Calculus 2 study guide. There's a link down in the description if you want to check that out, but it's available for instant download, so you can go get that today and start using it right away. So go ahead, actually push pause on this video real quick, go over there, get yourself a copy of that, pull up the PDF or print out that PDF if you prefer to have a physical copy, then come back and watch the rest of this video and I'll show you exactly how to use that formula on there. So I like to solve these problems using a table. I think that's the easiest way to kind of keep organized everything you're doing. And then we're going to use the formula on my study guide to fill in the table row by row until we get to our answer. So let's just go ahead and start with the formula that's on my study guide first, and then I'll show you what I mean by setting up the table. So this is just the information that we would need to be given, essentially. This right here is, so basically we know that we have some initial value problem where we have y prime equals some function of x and y, and then we have, you know, the point that is our initial point that this goes through. So we know that if we plug in x0 into our solution to the initial value problem, we would get out y0. So essentially what this tells us, in this case, we were given this equation, y prime equals xy minus x squared. So that tells us right there that we're going to have big F of x, xy, just is going to be xy minus x squared. And then we obviously would see here y of 0 equals 1. So our x0 is going to be 0. And our y0 is going to be 1. So we have the information kind of sorted out that we know we need in order to apply this formula. So to apply this formula, what we want to do is set this up in a table. And you could kind of think of this table almost like a Euler's method differential equation calculator, because what we're going to do is kind of go through it piece by piece and use this formula and the table to estimate the next estimate as we go along based on this step size here of 0.2. So what needs to be in our table, we're going to start with a column where we keep track of what n we're on. We're also going to have our x sub n minus 1 and our y sub n minus 1. And then we also want to figure out along the way what we get when we plug in our f of x sub n minus 1 and y sub n minus 1. And then we're going to use all these pieces to figure out our y sub n. So it really is just kind of up to personal preference. If you don't like keeping track of all these columns, you don't really have to, like especially this one right here. Really, I just like to break this formula down into the smallest possible pieces and keep track of each individual piece so that you don't get lost, because it's really easy to get lost when you're trying to keep track of all these different things. So I like to break it down into the smallest possible element of this formula and kind of keep track of all those so that when we put it all together, it's a lot easier to figure out what's going on. So to figure out what n's you need, you can pretty much start with that first. You know, really in this case, since it tells us that the point that we're given that we start at is x equals 0, right? So we have y of 0. And what we're trying to estimate is y of 1. So that tells us, using whatever step size is given, which in this case is 0.2, we're going to start with this y value that we know is on our solution, right? When x is 0, y is 1. And what we're going to do is use Euler's method to first estimate what the y value is of this solution when x is 0.2. And then we're going to estimate what the y value is when x is 0.4, and then 0.6, 0.8, and then 1. So we're going to basically need to go from whatever starting x value you have to whatever ending x value you need. And whatever your step size is, you would essentially take the difference of those two things. So in this case, to get from x equals 0 to x equals 1, our x needs to go up by 1, right? And the step size that we have to get from 0 to 1 is 0.2. So if we divide the x value that we need to get from minus the x value we're starting at all over your step size, that'll tell you how many n's you need, how many steps you're going to have to take. Well, doing this is going to tell us that we need 5 steps to get from our starting point to our end. So essentially our n can be 1, 2, 3, 4, and 5. Because that would represent the 5 individual steps that we have to take to get up to x equals 1. So then what you're going to do is you're going to just start with the x and y value that you're given. So we know when x is 0, y is 1 is the first one. So you're just going to start with those. Then what you can do is plug these two numbers, 0 for x, 1 for y, into the function that we figured out, right? Or basically the function that you're given. Whatever y prime equals is going to be the function that you plug that into. So we're going to plug 0 for x, 1 for y into this function here, xy minus x squared. So doing that is going to give us 0 times 1 minus 0 squared. And that's just going to be 0. And yes, things did change a little bit. I realized when editing this video that I made a mistake here. I accidentally said this was 1, but in fact 0 times 1 is 0, minus 0 is still 0. So I'm coming back and recording the second half of this video on a different day than the first half. But anyway, let's carry on here. So now with this final column here, this y sub n, basically what we can do is just use this formula that we have here, which is on my Calculus 2 study guide, and we can plug in these different pieces that we figured out so far into this equation to figure out this final column y sub n. So obviously we have this y sub n minus 1, we have that right here is 1. H is always going to be whatever your step size is. So remember, they told us our step size is 0.2, so h is going to be 0.2 consistent throughout this whole problem. And then this f of x sub n minus 1 minus y sub n minus 1, that's exactly what we just figured out here. It's just going to be 0. So right here we're going to get y sub n minus 1 is 1 minus h, which is 0.2, times the number that we have in this column here, which is 0. So that's just going to be 0 times 0.2 is 0, 1 minus 0 is 1. So now that we figured out this, we can just carry this piece down into the next column. So basically, whatever your previous y sub n is just going to be your y sub n minus 1 in the next column. To figure out your next x sub n minus 1, all you have to do is take your previous x sub n minus 1 and just add whatever your step size is. So in this case, our step size is 0.2. We're just going to get 0.2 here. And in fact, you actually can kind of just go down and fill all these out right at the beginning, because we know that we're just going to take our previous x sub n and just add 0.2 to it to get our next x sub n minus 1. So as a result, we already know that those are all going to be 0.2, 0.4, 0.6, and 0.8. So now, again, we can take this x sub n minus 1, this y sub n minus 1, and plug them into our f of x sub x, or f of xy, which is just comes from whatever our y prime is. Plug these x and y value in here to figure out what our next number in this column will be. And again, that's just going to be x times y, which is 0.2 times 1, minus x squared, which is 0.2 squared. And doing that is going to give us 0.2 minus 0.2 squared, which is 0.04. So 0.2 minus 0.04 is 0.16. Now again, we can then just take this formula from my study guide, plug in our y sub n minus 1, which is right here, plug in h, which we know is always 0.2, and then plug in this whole piece here, which is what we got in this column. So in this case, we're going to get 1 minus 0.2 times 0.16, and that's going to give us 0.968. I'm sorry, that's actually not quite right. Made another mistake here. This actually should be a plus sign right here. Our formula is y sub n minus 1 plus h times f of x sub n minus 1, y sub n minus 1. In this case, this previous step, that's not going to matter, because 0 times 0.2 is 0, whether we minus or plus, that gives us 1 either way. But here we're actually going to get something a little different. We're going to get 1 plus 0.2 times 0.16, which is actually 1.032. And then again, we're just going to be able to take this y value here, put it into our y sub n minus 1 in our next column, and then we're going to keep iterating through this process until we fill out our whole table. I'm going to fast forward through that part because it is going to be repetitive and it's going to be the same process that I just showed you for these first 2 rows. So go ahead and try the rest yourself. I'm just going to speed through this, kind of fast forward the video through this. So go ahead and push pause on the video, work through the rest of this problem by yourself, and then I'll be able to confirm whether you got the right answer or not. So after we iterate through this process all the way up to n equals 5, we end up getting in our y sub n column 1.194942. And that should be the answer that they wanted us to find, because that should estimate y of 1 based on the fact that we figured out we have to get up to n equals 5 in order to get to the point where we were estimating the answer that we were looking for. So this should be the answer that we're going for here, our estimate of the solution to this initial value problem that they gave us. So if you found this video helpful, please be sure to give it a like, subscribe to my channel. I'll be coming out with plenty more videos. I'm sure together we'll be able to get you some pretty good grades in calculus. And be sure to hit that little bell icon so you're notified when all my new videos come out. We'll crush it for the rest of the term together. Thanks, and see you next time.